You know, the world runs on these massive electric motors. They power everything from the water pumps in our cities to the giant fans in our buildings. But these industrial beasts have a pretty violent secret. And today, we're going to dive into what that is and the clever tech that tames them.
So that secret, it's all about what happens in the split second they're switched on. We're talking about these incredibly common squirrel cage motors. They're the rugged workhorses of industry for a reason. But they don't just start. No, they explode into action with a jolt of power so intense it can be incredibly destructive to everything they're connected to.
And check this out. The damage isn't just one thing. It's a whole domino effect. If you look at the older methods like direct start or start delta, you see a whole list of problems. You've got drive belts slipping and getting torn up, gears getting worn down, and get this, even the pipes can suffer from something called water hammering. It's this whole cascade of mechanical stress that leads to breakdowns and, you guessed it, really high maintenance costs.
So let's look at the most basic way to kick one of these motors into gear. It's called the direct online start. And honestly, the best way to picture it is just flooring the gas pedal in a car from a complete standstill. It's simple for sure, but it is incredibly harsh. The moment you flip that switch, bam, the motor tries to draw this enormous rush of current. We're talking 6 to 7 times its normal running level, sometimes even more. This creates a really violent jerk of torque, just this huge, unnecessary shock of force that puts a ton of stress on every single component down the line. Now, engineers have known this was a big problem for a long time, so they came up with a workaround called a star delta starter. It was a pretty clever mechanical attempt to kind of soften that initial blow, but it had a huge flaw of its own. And here's the catch. The star delta starter does reduce that first jolt by starting on a lower voltage. But, and this is a big but, to get up to full speed, it has to physically switch over to the main power connection. And that switchover? It creates another massive, damaging shock to the system. So, it basically solved one problem by creating another one a split second later. And that, right there, is where our hero finally enters the scene, the soft starter. This is the elegant, modern solution. It's all about replacing that old-school brute force with some much-needed intelligence. So, instead of thinking of it like a simple on-off switch, picture a soft starter as a dimmer switch, but, for a motor that might weigh several tons. It uses these really slick electronic components called thyristors to precisely control the voltage, feeding it to the motor in a perfectly smooth, manageable way. And this is how it works its magic. It starts the motor off at a really low voltage, just enough to gently get things moving. Then, it smoothly ramps up the voltage over a set amount of time, giving the motor exactly the amount of torque it needs to get up to speed without any drama. No jerks, no current spikes, just a controlled, gentle start. So when you put all three side by side, the evolution is just crystal clear. Direct online is just pure mechanical shock. The star delta method just delays that shock, but the soft starter, it eliminates it completely. This isn't just a small improvement. It's a fundamental shift from brute force to finesse. And this isn't just some abstract theory. This technology is out there solving real physical problems in these huge systems that we all rely on every single day, often without us even knowing it. For example, take the pumps that move water all through our cities. When a powerful pump just slams to a halt, it can create a violent pressure wave in the pipes. That's the water hammer we talked about, and it can cause serious damage. A soft starter can also ramp the motor down, a soft stop. It gently slows the water flow and prevents those destructive shocks from ever happening. Or think about the giant fans in big ventilation systems. That sudden jerk from a direct start, it makes the drive belts slip and just shreds them over time. By ramping up the motor's torque gradually, a soft starter gets rid of that violent kick, the belts don't slip, and that means a whole lot less downtime and way lower maintenance bills. So ultimately, it all comes down to this one simple idea. Soft starters replace mechanical shock with intelligent control. By being gentle where the old methods were violent, they make critical equipment last so much longer. They slash maintenance needs, and they just make our whole industrial world run more smoothly and reliably. It really makes you wonder, doesn't it? As we look at all the machinery and systems that power our lives, you have to ask, where else could a little bit of intelligent control replace brute force and make a massive positive difference?